Okay, I'm going to do some examples of clearing equations of fractions. So starting with the one that you see on the screen there, 1/2 x plus 2/3 equals 1/6. Now, if you really love working with fractions, you could just solve this as it is. But it's a lot easier if we could get rid of the fractions. So I'm going to show you two different ways to do this. So I'm going to write it down twice on the screen here. Okay, both of these are going to involve needing to look at the denominators and come up with a common denominator. And we know from when we've done these before that a common denominator or least common denominator is the same thing as what we call the LCM, which is the least common multiple. If you look at the three denominators, the LCM, or the smallest number that 2, 3, and 6 will go into, that would be the number 6. So for this particular problem, the LCM equals 6. And we're going to write that down when we do our assignment problems. So I'm going to want to see what your LCM is. The next step would be to take both sides of your equation and multiply by the LCM, which is 6. 6 on the left, 6 on the right. Now notice how I wrote these. I wrote them equal in height to the numerators of these fractions. Don't write the 6 down here in the middle. I have students that sometimes, if they do that, if let's say they write the 6 right here, I find that sometimes students multiply it times the 2 instead of the 1. So instead of doing that, what we're going to do is we're going to multiply by 6, and we're going to write that 6 on the top. And now if you want to, you could put it over 1. I just don't want you to think that you're multiplying the 6 times the denominators. Okay, so next step is distributive. So I need to multiply that 6 all the way through, and I get 6/2 x plus 12/3 equals, and now on the other side I get 6/6. If I simplify that, I get 3x plus 4 equals 1. Well, that sure looks a lot better than what we started with. That's just a simple two-step equation. I can subtract 4 from both sides and get 3x equals -3, then divide by 3, and it looks like my answer is x equals -1. Okay, so what we need to do is we need to find the LCM, and then we need to multiply both sides by the LCM. But I want to show you a shortcut, because notice what happens here. If I have more than one term here, this 6 gets connected to both of these with multiplication. So why not just start by writing the 6 beside both of those instead of having to do the distributive with the arrows and the parentheses and all of that. And I also would have to do it on the right side. So we call this multiplying through all of the terms by the LCM. And the advantage of this is that I can then cancel. 2 goes in here once, 2 goes in here 3 times. 3 goes in here once, 3 goes in here twice. 6 goes in here once, 6 goes in here once. And then I end up with 3 times 1 times x, which is 3x, plus 2 times 2, which is 4, equals 1/1, which is 1. So notice then, this is the exact same equation we have there, so it will work out to be the same exact answer, x equals -1. Now the reason I prefer this method, it's faster, plus you get to cancel. I often find students make the mistake, if they put the 6 on the outside, they'll do this. They'll say, oh, 2 goes in here 3 times, 2 goes in here once, and then they think they should take 3 times this and 3 times this, which is not going to give you the correct answer. So I'm going to show you some more examples of this. This is a great way to get rid of fractions and get your equation into something that looks much simpler. For this equation, when I look at the 3 denominators, the least common multiple, which is the same as the least common denominator for those 3 numbers, is going to be 24. So the LCM equals 24. Next, you're going to multiply that LCM all the way through both sides of the equation. After you do that, you're free to cancel. Once, 8. Once, 3. Once, once. When you finish, all the denominators should be gone and just multiply what's left on top. I get 8x plus 3x equals 11. If I continue solving, I get 11x equals 11. Divide by 11, and I'm done. And my solution is x equals 1. Here's another problem. In this one, I only have one denominator. That's awesome, because then I can say that my LCM is 5, and I can multiply through by 5. I need a 5 here, I need a 5 here, and also with the 12. So when I go to cancel, 5 goes in here once and in here once. So my equation ends up being 5y equals 3y plus 60. And then I can finish solving that. And you get the answer of y equals 30. Okay, let's look at this problem. It's a little different because I've got some extra stuff up here instead of just a single number or a variable. But the process is the same. I'm going to look at my denominators, 3 and 5. This has a denominator of 1. So if I want to, I can put it over 1. But in any case, my LCM is going to be 15. So I need a 15 here, a 15 here, and a 15 here. Now, before I do anything, it's super important that you realize that this 15 is multiplied by this entire quantity. So if you've got more than one term up here hooked with a plus or minus sign, one of the first things you should do when you start is get that guy in parentheses. Because when I do my canceling, 3 goes in here once and in here 5 times. 5 goes in here once and then there 3 times. Notice what happens. I've got a 5 now that needs to get multiplied times this entire quantity. And if you don't put the parentheses down, chances are you're not going to write down 5x plus 5. You might just write 5x plus 1. But we have to multiply 5 times the x and 5 times the 1. So what I have here, if I just write it without doing all of the multiplication yet, this is what I have. So you can see whether you look here or whether you look here, we have got to distribute the 5. So I'm going to get 5x plus 5 plus 6 equals 150. And then we can finish solving. And there you have the final solution. Okay, let's talk for a second about clearing decimals. In this equation, you can see that this term has 1 decimal place, this term has 1 decimal place, and this one doesn't have any decimal places. So what we do is we look at the greatest number of decimal places that we need to clear, and we multiply by that power of 10. So in this case, I'm going to multiply by 10 all the way through. So let's see what that does. When you multiply by 10, you in essence move the decimal place 1 spot over. So 10 times 0.5 is going to give me 5. So I've got 5x. 10 times 0.3, moving the decimal point over 1 place, is going to give me 3x. And 9 times 10 is 90. So let's look at that again. What I did is I multiplied by 10, which moves the decimal point 1 place in all of these numbers. Now over here, because there wasn't a decimal point, I would have to put a 0 after that 9 to get the 90. All right, now this is a simple equation. I can go ahead and solve it, subtract 3x from both sides, and I get 2x equals 90. Divide by 2, and my solution is x equals 45. Okay, let's look at another one. Okay, let's look at this problem. This term has 2 decimal places that I want to get rid of. This has 1, and this has 2. So you have to go with the greatest number of decimal places that you need to get rid of. So in this case, my LCM, or the number I'm looking to multiply through by, is 100. That means 2 places. So over here, this is how I can do this. 2 places, 2 places, got to put in a 0, and 2 places. You don't have to write 100 beside each of those terms. You can just do the 2 places. Okay, so that leaves me with 12x plus 410 equals 446. Okay, to finish solving that, I would subtract 410 from both sides. And that gives me 12x equals 36. Divide by 12, and I get x equals 3.